everybody. My name is Bhardwaj. I am a co-founder of Viman, and I will be presenting Orbit to you today, which is our primary product, along with Aniansh, Singh, Rajput, Bassam, Pervej, and of course our faculty mentor here, Dr. Sayan, Basu. Now, what is Orbit? Orbit is essentially the online replacement of batteries in transit. What you can take of it is essentially a petrol pump for drones. As you can see from the infographic here, what it does is a drone takes off for a particular mission, a long-range mission, in which it will require to swap its battery multiple times during the mission itself. Once it's at a state of critical battery or low battery, it locates a battery swapping station within its vicinity, docks on the platform, drops the depleted battery that it was currently using to fly, and the station itself will swap in a brand new battery, a charged battery, into the drone, and the drone can resume with its mission. Essentially what this does is extends the duration of a mission to an infinite amount of distance, without all of this can be done without any delay. We can talk about why we swap. So the average professional commercial drone has an average flight time of 20 to 30 minutes without any payload, which is a really big restricting factor. You see, communication links now are essentially with an infinite range, looking for onboard navigation, so communicating with a drone is no longer an issue, and the only issue that remains now is battery life. So the solution that we can look into there is swapping discharged batteries for brand new and charged batteries, right? We can also talk about the Indian drone economy. The Indian drone economy is projected to be around 120 to 150 crores industry in the near future, and major companies are investing in drone delivery systems, and we're looking at smart cities that are taking place all across India, and a major role there is based on drone delivery systems. And for that, we need to be working as an international drone hub. That is the goal that India is setting up towards. Many MNCs have already taken to drone delivery systems, whether it be Prime Air or Zomato and all of these other food delivery companies that are looking into drone delivery systems. So there's an inherent need for battery swapping mechanisms for drones, and currently there really aren't many solutions. The solutions that do exist are either prohibitively expensive or too slow for urgent missions. I mean, we're talking about excessive of 3 minutes to actually swap batteries, and they're over-engineered to the point, some of them, that they're infeasible to deploy in the market and only suitable as base stations for single drones. Now, this is one of the biggest points. Most of these solutions are single drone housing units, not battery swapping stations. There currently is no battery swapping station that we're aware of in the global market, let alone the Indian market. And added on top of that, none of these solutions are yet commercial. So a few drawbacks that we identified here in the previous solutions is that they're not open source, and essentially they have time constraints and monetary constraints. They're extremely expensive, some of them, and some of them require excessively long times to actually swap the batteries. So what we want to do is we want faster landing, increased accuracy, faster swapping, and at the same time maintaining a solution that is within monetary restrictions. Now, what we do for our solution is we use multi-visual marker setups and IBVP, which is image-based visual processing, for precision landing on a particular drone swapping station. We also have modular battery casings for efficient swapping times, and we'll get into a lot of these solutions further ahead. But what we really do want to emphasize is that our solutions have minimal time constraints and monetary constraints. So the flow that we've worked through is we've synthesized the drone, we've used Aruco markers and IBVP for precision landing, and we've designed a swapping mechanism which is very, very time and cost effective. We use an LDS system. An LDS system is essentially a land, drop, and swap system for our entire mechanism. So the drone lands on a platform, drops the depleted battery, swaps in a new battery, and is ready to take off with its mission. Essentially, the workflow is that the drone comes into a particular area within vicinity of a swapping station using GNSS. Then it uses IBVP-based precision landing to land on the station with extreme accuracy, so that we're able to actually swap the battery station, and there is no issue in terms of having multiple degrees of freedom on the battery swapping station to place the batteries in. And lastly, we can talk about the implementations that we've done. So the implementation here, will also be playing a video for you after this presentation regarding our developments. But here you can see some of the IBVP, the origin being fixed for precision landing. You can see some of the prototypes that we worked through. This is the battery holder and the drone side battery mounts here. You can see in this particular video images. And these are actual prototypes. These were 3D printed prototypes. These are prototypes that we're currently working on, and of course they have been iterated along with the movement of our company. We can talk about the final stack, essentially, just to show you really quickly here, is that the battery goes inside a particular pack, and these can be varying size batteries. As you can see, this isn't a perfect fit, so this allows for higher capacity batteries to fit into that pack. Then this is a mount, which all goes on top of your drone. So this will be attached to the drone and it will fly as a particular system here. Here you can see that it's connected and all of the things are working and implemented here. But moving forward, what we can talk about is the platform. This is a prototype of the platform. You'll see it in action in the video that we play later. But what we want to emphasize is cost and time. We're really saving a lot on these, and our solution is out of the box instead of being in the box, as most of the solutions are taking place currently. So there are three things that we're going to be providing as products. One is going to be the drone side battery mount, the other is going to be the battery holder that you saw there, and the last is going to be the actual platform, which is able to put in charging the discharge batteries while at the same time being able to swap in new batteries into drones that are coming in. So this leads to an extremely flexible and easily adoptable solution, right, for drone manufacturers. Even fitting in our entire system into drone manufacturers and their current drones is just a simple task of retrofitting, which is not too difficult. And the potential impact, this is what we're all looking for, right? So effectively, flight time with orbit will become infinite. Your operation range again will be however many stations that you have. You'll be able to process those entire areas. And time spent on charging versus orbit, of course, orbit is able to swap batteries within a minute, and whereas charging a battery for a drone takes over 2 hours or at best 1 hour, right? So if we look at the numbers, we're looking at effective vehicle uptime going from 33% to 97% with the use of orbit. India is, as we talked about earlier, leading towards becoming an international drone hub. For that, we need indigenous infrastructure for the Indian drone economy to flourish. And these are going to be used, again, in smart cities, geo-mapping systems such as Map My India, geopolitical border surveillance areas, drone delivery systems, swarm robotics. All these places require a drone battery swapping mechanism. And no one really has tapped into this market yet. So that is our final goal with Orbit. And now we have a short video. I'll be logging off to demonstrate what.
We have here all of the prototypes for the components that we've made. We have the drone itself, the battery mount, which goes inside the drone like so, the battery housing mechanism, the contact switches, and the station itself. That's it. So here we have the Aruku board being detected by the camera. We're using multiple Aruku markers of different sizes to get a more precise location of the origin, as you can see at varying angles, and as we vary the depth, the origin seems relatively fixed on the board itself. Here we have the spring-loaded contact terminals. As soon as they make contact, it's turned on and we can have some vibrations and the power is still continuous. Here we have the actual mount, which is going to go on the drone, and the battery is going to be inside of it. So as you can see, it turns on very well. Next we have the actual platform itself, and the platform rises. The drone then drops the battery. The platform comes back to its rest position. The drained battery is then dropped from the board as the new battery comes in. This is all achieved with stepper motors. The platform rises. With servos, the battery comes back into place and the drone is ready to take off with a replenished random battery.
Take off light roll.
Yo, just waking up in the morning and to be well. Quite honest with you, I ain't really sleep well. You ever feel like your train of thought's been derailed? That's when you press on, lean in. Half the population just waiting to see me fail. Yeah, right, you better off trying to freeze hell. Some of us do it for the females. Yeah, and others do it for the kids. For the kids, like the time we're in on every time we go out. And I'll